All right. Hello, everyone. Thank you for attending our webinar today on QoS deployment strategies using LiveAction. I'm Clark Zeller, and I will be the moderator today. I am a sales engineer for Action Pack Networks. My background is in unified communications. Over the last 15 years, I've been an engineer and a consultant deploying large-scale voice video systems as well as network infrastructure, and I have a lot of practical hands-on experience with QoS. So the agenda that we're going to follow today is we're going to begin with our brief introduction. We'll then have a very brief QoS concept review. We'll follow that with a technical deep dive, and we will end with a section on QoS deployment strategies. Now, as a matter of housekeeping, the first thing I'd like to say is thank you for all of the registrants that have pre-entered questions. We tried to tailor the conversation to your questions. As well, this web meeting that we are attending is being recorded, and it will be posted online very soon. And then finally, if you have any questions throughout our time today, we have a panel of experts available to answer your call or questions. If you will utilize the meetings console, you'll be able to ask questions via that as the conversation progresses. So with that, let's start by talking about our QoS concept review. And when we're talking about QoS, all we're really trying to do is we're trying to protect our high priority data, our voice and our video, as it crosses over our network. So since it's infeasible to purchase enough bandwidth for all of our applications to run all the time, we need some system of prioritization to allow our critical applications to get where they need to go when they need to be there. We also need to understand that QoS is not just one technology. It's actually a suite of tools that are all used in conjunction with one another. Very rarely will we deploy any one of these technologies on any one device. Typically, we're mixing and matching the technologies on different areas of our networks to formulate a holistic enterprise-wide QoS policy. We also need to understand that not all devices are created equal. For instance, Cisco enterprise class devices typically have the full QoS tool belt at their disposal, where traditionally Cisco enterprise class switches do not. With that said, Cisco enterprise class routers will do QoS in software, where switches will do QoS in hardware. So whenever possible, it is best to implement QoS at the switch or LAN level. But do keep in mind that switches do not have the full tool belt at their disposal. Well, where exactly do we need QoS in our networks? Well, the easy one is going to be at the WAN edge. This is where congestion is most likely to occur, as our very high bandwidth data center and remote LAN environments will be trying to transmit lots of data over usually much smaller WAN environments. As well, in many networks, it is a requirement to have QoS at the LAN level too. With that said, though, if you're just getting started with QoS, I would highly recommend that you only implement QoS at the WAN level. Once you have confirmed those QoS policies and validated that your critical applications are being treated appropriately, only then turn your attention to your LANs. So next, we're going to enter our QoS technical deep dive. And for our deep dive, the main question we're going to be answering is how exactly do we implement QoS? Well, I have set aside 4 specific steps that I've personally used for my customers to successfully deploy QoS, and we're going to talk through each of these steps. I would highly recommend, as you look to deploy QoS in your own networks, to follow these steps in this order, as most of the time this is the order that you will want to do this. So step 1 in deploying QoS is all about network recognition. We need to teach our routers and switches, our network infrastructure, to understand the types of traffic passing over them. And once we've done that, they can then implement other QoS tools such as queuing, policing, shaping onto the traffic. And the way I think about this is going from black and white to color. So once we have network recognition, classification, and marking in place in our networks, our network devices can recognize each color, if you will, and understand what type of traffic that is and apply the appropriate policy to it. So the way we classify traffic is one of several ways, and the best way typically is by setting DSCP values. This is a toss byte that is going to be in all IP headers, and by flipping various bit combinations in the TOS byte, you will be setting different priority markings that our network infrastructure can recognize and then understand what to do with that specific setting or QoS marking. The next way we can recognize traffic is via ACLs or access lists. This is a traditional way to match traffic based off source or destination IP address, network, or TCP and UDP port range. The next technology we'll mention is that of NBAR. This is a Cisco-specific technology, and what will happen is our Cisco infrastructure can do a deep packet inspection, discover the types of applications flowing through them, and then our QoS mechanism can reference NBAR's table of information and allow us to very easily classify traffic. And finally, I'm going to highlight a very new Cisco technology called MediaNet metadata. This is where our applications as well as Cisco MediaNet proxy servers can generate an RSVP announcement. Our infrastructure will be on the lookout for that RSVP announcement, and then we'll very easily be able to classify and mark what is traditionally very complex traffic streams. A good example of this may be Cisco's Jabber. After we have taught our networks to recognize traffic, step 2 in our QoS process is to prioritize traffic. This is our queuing and shaping tools. And when we start talking about prioritization or queuing, this is one that folks typically associate with QoS, and it's just like it says. We take a specific traffic stream and we give it a amount of bandwidth that will be guaranteed it. There's two types of queues. One is priority queuing or low latency queuing. This is our very high priority traffic like voice, sometimes video, that we want to always go to the head of the line traffic. So if there's any of those types of traffic needing to be sent, they'll always be sent as soon as possible. Other types of traffic, critical data applications, will implement something called class-based weight fair queuing, and this is where we can guarantee bandwidth to various application streams. Now, also at the prioritization step, this is where we want to implement shaping, and this is specifically hierarchical shaping. And if you're not familiar with shaping, what this is where via software we can throttle the transmission rate of data to a software set limit. If this software set limit becomes congested, we can then queue that data with a queuing policy and ensure that our critical applications are allowed through that software set limit. This is very often utilized in high bandwidth WAN environments where a service provider will be offering some sort of subrate service or having a CIR in place. Now, step 3 of our QoS implementation process is that of buffer tuning. Now, this is definitely an advanced topic, and I would not recommend implementing this step until you are very familiar with the rest of the topics that we're going to discuss today, but it is also important as part of a QoS strategy. Just be aware that these steps do exist, and this is where we would increase or decrease the size of the queue buffers on our devices to ensure that our infrastructure devices do not drop our critical data. Step 4 of our QoS process is that of throttling traffic. This is where we will implement policing as well as red. And what this is where administratively we will drop some traffic for the greater good of the network as a whole. So now that we've briefly talked through the steps we need to take to implement QoS, what I'm going to do is I'm going to shift gears. I'm going to flip over to a lab environment and show you all of the things we just discussed in very practical terms. And I'm going to do that with a tool called LiveAction. And LiveAction, if you're not familiar with it, it is an application-aware network performance management tool with QoS control. And what I mean by that is it is a tool that will allow us to enable the latest and greatest NetFlow technologies into our environments. We can collect NetFlow stats. We can also now collect application performance statistics from our routers and switches, quite literally turning them into probes. And then LiveAction was originally designed to be a QoS management tool where you could create, modify, as well as deploy QoS very simply, and most importantly, validate your QoS policies on the fly. So that's the tool we're looking at. And if we take a look at what's happening on my screen, what we're seeing are two devices. The device I'm highlighting here, this larger circle, represents a router. And if I zoom in on this device, I can see the smaller circles represent the interfaces. If I really zoom in, we can see the real-time bandwidth statistics of what is flowing through each interface. Now, as I zoom back out, what I want to highlight is that this data center device here to the left has a data center LAN to its left and a handful of devices that I've annotated on that LAN. This data center device is connected to an MPLS cloud in the middle of my screen, and notice how we have annotated that the MPLS provider does have a 1 megabit CIR in place. To our cloud's right, we have a remote site, and off to its right, we have a LAN environment as well as some remote site devices that we've also annotated. So what I'm going to do is I'm going to click on the Flow tab, and what I now see on my Flow tab are multiple arrows, and these represent different flows of data that we've collected via NetFlow from the devices we are seeing on the screen. Now, what's very unique about LiveAction is we have the ability to not only map out a network, this is a very simple example, obviously, but we can also correlate flow data and paint an end-to-end picture of how traffic is traversing your environment. So what's great about this is right now I'm looking at all the traffic flowing over this small network, and I can see that we are looking at this traffic based off DSCP value, or the quality of service markings that are set on the various traffic flows. Notice how all of the arrows I'm looking at right now are light blue, and this stands for best effort. So what this means is right now the network environment we're looking at has no knowledge of QoS. It sees all traffic as the same, and we definitely need to fix that. But before we do turn our attention to fixing our matching and marking issue we're looking at, let me quickly show you some more of the features of LiveAction, and I'll tell you why this is important to QoS. So one thing we can do is I'm going to double-click on this device. And when I do, I see all of the raw, real-time NetFlow information that we're collecting on this device. What we're looking at is basic traditional flow. So we're going to see our source and destination IP addresses, source and destination port numbers, our input and output interfaces, etc. To the bottom of the screen, we can see a graphical representation of all of the traffic passing through this environment. Now, this is what's happening in real time. What I can also do in LiveAction is we have the very complete set of historical reports that we can run on our flow traffic. And I'm going to run a time series report that's going to show us all of the traffic passing through that data center router. In this case, I'm looking at that traffic for the last hour, and we can see very easily at a glance who are the top talkers passing through the network environment. One thing that's great about this is I'm going to uncheck my top talkers, and I'm just going to highlight one specific traffic flow. Now, what I'm highlighting this for is I'm going to drill down and see very granularly what is the transmission rate of this specific traffic flow. Now, what's extremely important to understand about LiveAction is we will never average or aggregate any data. So as long as you give us enough disk space, we'll always be able to go back in time and show you exactly what's happened for any of your applications and any of your traffic flows across your network. When this comes to QoS capacity planning, this is very important, so you get a near real-time view of exactly what's happening, and out of doing that you'll know exactly what size to make your queues, etc. So the type of historic data we can use with LiveAction is we can look at historic data in a 15-minute increment, hour, last 6 hours, last day, or we can even run custom time periods. So let's say we want to see exactly how one interface was performing 3 weeks ago on Thursday at 2 p.m. Well, using our flow capabilities, we can drill in and do this. Now, as I look at this traffic, again, I'm going to highlight all the traffic passing through this interface, and I notice a couple of applications that concern me, especially when it comes to QoS. Notice how I see some BitTorrent traffic passing over this interface. Now, that's definitely a problem that we want to understand further, and what I can do with LiveAction is just right-click on the application BitTorrent and then drill down into BitTorrent and understand exactly who is utilizing BitTorrent. I'm going to run another report, and now I can see exactly who in my environment is utilizing BitTorrent. Notice how BitTorrent in total is using 200K of data. We're mapping out that there's 2 users based off 2 color codes, and down here in the table view I can see which IP addresses those are, and if I wanted to I could then go hunt down these users and have them no longer use BitTorrent on our network. So when it comes to network capacity planning, LiveAction is definitely a great tool for that as well. So I'm going to now turn our attention back to our original problem that we were looking at, and that is of all of our traffic being marked with only best effort. And let's fix that. And the way we can fix that is I'm going to go to our QoS tab and double-click on our data center device. And what we see on our data center device is a list of the interfaces being managed by the tool. And to the middle of the screen, I can see that there are a couple policies already in place. The WAN interface, which is FA4, has a queuing policy, and the LAN interface on the data center has a QoS policy named No Trust. But based off those names, I can guarantee you that is exactly what's happening here. And that No Trust name concerns me. So let's take a further look at exactly what is happening with that no trust policy. And what I can do with LiveAction that is very unique is I've gone to our Manage QoS Settings dialog wizard. And what this is truly a replacement for the iOS's MQC QoS configuration. So quite literally, you can replace all of your QoS configurations with this tool that are MQC related. And if I wanted to, I could drill down and see exactly what is happening in this no trust policy. I've highlighted it, and I can see in this specific policy in the summary that has a class default, so all traffic is going to hit this class, and we are remarking or marking data with a best effort value. So this is definitely a problem for us. Now, for the sake of time, I've actually already created an applicable policy that will fix this issue. And before we dive into what that policy looks like, I'm going to go ahead and apply that policy now, and then we're going to talk through its details and see exactly what is it doing. So I'm going to implement a set DSCP policy. And this would be very similar to the type of policy that you would implement on your network, whether it's at the WAN edge or within your LAN environments. And taking a closer look at this set DSCP policy, we can see that we're matching some VoIP traffic based off DSCP value. We're also matching video traffic based off the SCP value as well. I have some call signaling traffic, and in this specific case, I'm matching my signaling traffic based off NBAR, and I'm matching both skinny as well as SIP. Those are two voice over IP as well as video signaling methodologies. And then I'm also matching Citrix traffic, and in this network example today, we're going to consider Citrix a high priority data application throughout our discussion. And then finally, we do have our class default. So that is the type of configuration that we have in place now on our LAN. And hopefully this will allow our network to understand what is happening across the network. And before I leave this topic, what I do need to highlight is if you look in the summary section of this policy, notice how we are marking various DSCP values on the various traffic classes. 1 second before we leave this screen, what I want to highlight is this, is we can actually very easily update this policy or any one of the classes within this policy. Right now I've selected this match video class, and if I wanted to add a new match type to this class, what I can do is click the edit button and select any of the match criteria that are available in our iOS. And what I'm going to do is I'm going to actually match on an access list, and I already had an access list in this configuration named link video ACL, and I'm going to click to add that as a match statement, and that simply I've now updated my video class with a new match type. If I click Preview CLI, I can see where LiveAction has generated the appropriate configuration for me. I never have to go to the command line and deal with its complexities anymore. Using this tool, it's very, very simple to deploy QoS. Since I like that change, I'm going to go ahead and click Save to Device, and I will close this window for now. And I'm going to go back to our home screen and back to our flow view. And remember how end-to-end throughout our network topology, we were looking at all light blue arrows? Well, I'm going to go back, look at our default filter group, and refresh our flow information, and notice how now we see multiple color arrows passing over our network environment. Each of these arrows represents a different DSCP value or different prioritization level on the traffic passing through my network. So what's so powerful about this is, let's just say I want to focus in on one specific flow. I'm going to focus in on this red voice over IP flow, and I'm going to implement a custom filter and just look at that one conversation. Now, I do have IP phones annotate on either side of this conversation, but the way I know that this is voice over IP is based off the matching and marking policy. We know that it's marked with a DSCP value of 46, which is EF, and it has a red color. And end-to-end, we can see that red color passing through the network, so we know we have a good QoS policy in place when it comes to matching and marking. So in essence, we have now completed step one of our slide presentation. So let's do this. Let me show you what's something extremely powerful about LiveAction. And I'm going to double-click on this device, and instead of looking at my basic flow tab, I'm going to select the MediaNet tab. And what LiveAction has the ability to do is it actually will work with the latest Cisco technologies, which is in this case, NetFlow version 9 flexible templates. Now, what Cisco will do with these flexible templates is they will now take application performance statistics from voice and video calls that are passing through their backplanes, and via NetFlow version 9 flexible templates, they can send us, LiveAction, the details of the calls and the type of statistics we'll be able to get from the MediaNet flow type. This is actually MediaNet perfmon, as you'll see it documented, is things like packet loss as well as jitter measurements. So utilizing this tool, we now have quite literally turned this router into a probe and know how is my voice over IP performing across this WAN environment. To make things even better, check this out. I can actually at a glance understand exactly how my voice is performing across this network environment. What I'm going to do is I am going to execute a media trace on this one specific flow. And what a media trace is think of it like a trace route on steroids. But instead of pulling next hop information, we can pull voice and video call stats hop by hop by hop through the network. Now, if a network device in the conversations path does not support media trace, our devices will just respond back with a trace route. And here in a second, once we get all of our data back, let's see if we do not see some issues. And yep, there we do. Now we have some call quality issues that we're highlighting. So what we have here in this table, the first column is showing us things like jitter, packet loss expected. The second column is the first device in the conversations path. Notice how we have no packet loss being highlighted in green for us. The second device in the path, which happens to be a service provider device, the service provider device in this case is not media trace capable, and this is exactly like you would see in the real world, but it is responding to trace route. So we are getting some trace route measurements back from the service provider. And the third hop in this conversations path is our remote site. And so what this means is our remote site, based off this amber color, is highlighting for us that there is active packet loss happening on this WAN environment. So at a glance, we can track one unique call through the network and understand exactly how is it performing. So let me tie all this back to our QoS conversation, because this is really quite an important concept to understand. I'm going to dive in and look at this data center device's QoS policy, since our traffic flow that we're looking at is going from west to east. This will be the device closest to the source. I'm going to double-click on this device and go to the QoS tab. And now we can see on this device that we have our set DSCP policy on the LAN and a queuing policy on the WAN. So that's looking good. But I want to see the configuration details as well as the performance details of this policy. And what I can do is double-click on this interface on the output side of this interface, and I can see the traffic statistics of this specific interface. And so to the top of the screen, what we're seeing is our NBAR data, and this is where our Cisco device is doing a deep packet inspection and discovering the applications flowing through it, and it's reporting it back to us, back to LiveAction. And so the bottom half of the screen, what this is a graphical view of the QoS policy on the specific interface, and it's showing us how this policy is performing. Now, if you notice, we are seeing several classes or queues here, and we can see that we do have traffic hitting each of these applicable queues, and that looks good. If I right-click on any one of these classes and go to Adjust Output QoS, LiveAction will actually give us a summary of this specific policy's configuration, and we can adjust this policy on the fly. But what's great about this is, at a glance, I can confirm how is this QoS policy configured. We can see our queue names, our queue types, the bandwidth settings for each of the queues. I can also see a percentage breakdown at the bottom of the screen, highlighting for me how have I allocated bandwidth to each of these queues. So I think this all looks pretty good, and this makes sense. But what I want to do is I want to go back and look at our network as a whole. Remember how we were seeing call quality issues on this device, but we have a queuing policy on this device. What gives? Well, let's notice how our service provider has a 1 megabit CIR. If I double click on this device and look at the real-time performance stats again, notice how all of the traffic passing through the WAN interface in my data center device is peaking out, at about 3 megabits. So what we can tell here at a glance, based off these real-time bandwidth statistics, that we are definitely sending the service provider more than 1 megabit of data. Now I'm going to zoom out, and I've had hidden from view a service provider device. Now obviously this is a lab environment, and in the real world the service provider would never give us this type of visibility in their cloud, but since it's a lab, we can take advantage of this. And if you'll notice, this specific device labeled service provider that we're managing in LiveAction is Amber, and more specifically, this interface here is Amber. If I double click on this interface, I can see that this interface has a QoS policy on it, and this QoS policy is dropping traffic. I know that by its amber color. If I right-click on that amber class or queue, I can see in the red line in this queue's real-time statistics that we are actively dropping traffic, and a lot of traffic in this class for this queue. So what this actually means, we can see that this device, or the QoS policy on this device, is labeled police. So what we are able to confirm by doing this is that our service provider is actually enforcing that 1 megabit CIR. If we again double click on this interface and look at the bandwidth transmission of this interface, notice how it truly is limiting the amount of bandwidth it sends out the interface post QoS policy at right at 1 megabit. So if I come back to my home screen, what is actually happening is, even though I have a QoS policy on the WAN interface on my data center device, I'm sending the service provider too much data. The service provider is honoring their CIR, and they're dropping traffic. So what this means is we need to enable a shaping policy, just like we talked about in our slide presentation. So what I'm going to do is I'm going to right-click and go to Manage QoS. And I'm going to update this policy. Instead of having a queuing policy attached to my WAN interface, I'm going to remove that, and in its place, I am going to apply a shaping policy. There it is, and I already had that shaping policy pre-canned just to save us time. I'll click Save to Device and go ahead and implement that shaping policy. And now let's drill down and talk about what this shaping policy looks like. This is a very common configuration that you see these days, and what's happening in the shaper is we have one class. It's a very simple shaping policy, and that one class does have a shaper. I've come over to my shaping tab, and I can see I have a shaping rate of 1,000 kilobits. This would equate to 1 megabit of data. So what we're doing is we are, via software, telling this device to no longer send a full Ethernet interface worth of bandwidth, but instead only send 1 megabit of data, which in turn will have the service provider never dropping any data, because he's going to drop anything over his 1 megabit CIR. So we're conforming to the service provider's policy. We then have made this QoS policy hierarchical. Notice how we have a child policy named queuing. It's actually the exact same queuing policy that was applied to the physical interface just a moment ago, but now it's going to behave based off of 1 megabit transmission instead of the full interface's transmission. So now that we have that in place, I'm going to close this window, and let's take a look at the real-time traffic statistics we are now seeing on our data center's WAN interface. Notice how it is now sending right at 1 megabit very consistently. We can also see that we have several Amber classes or queues on this specific QoS policy, and that means that these various queues are actively dropping traffic. Now, I happen to highlighted a queue labeled Citrix, and what we're seeing in this Citrix queue that's actively dropping data, remember this is going to be a high priority data class in our example today, is it is dropping traffic. Looking at here at these real-time statistics, at about 25K, we may see it bump up a little more than that. But what this means is we need to increase this specific queue size by minimally of around 25, 30, maybe even 40K to be able to contain all of the traffic, all the Citrix traffic we're trying to send out that queue. So let's update this Citrix queue and ensure that it's not going to drop any of our prior data since it's not sized appropriately. So I'm going to right-click, and I'm going to go to Adjust Output QoS. And let's say that we want to actually reserve about 50K total for our Citrix application. Here's our Citrix queue or class that we see in our summary or our just output QoS policy wizard. And I'm going to change this. Instead of looking at 1%, that would be 10K, I'm going to make this 5%, which would be 50K of data for our Citrix. And I'm going to click Preview CLI. That looks pretty good. I'm going to allow LiveAction to make that change. So I'm going to go ahead and click and push that change to this device. While we wait for SMP to catch up, I want to turn your attention to a red alert button that I see at the bottom left of my screen. I'm going to double click on this red alert button, and what we now see is a list of all of the alerts LiveAction has been collecting. And the type of alerts that we can highlight and warn you about are things like packet loss as well as jitter from MediaNet technology. So you can actually be warned about when your applications are failing or your calls, your voice and video calls are failing. You can also be alerted to things like packet drops or queue drops on your QoS policy. So truly, before your end users complain about performance issues, either from a QoS perspective or an application perspective, you can be notified by this via LiveAction. Now, these alerts we're looking at can be sent to you in both email as well as syslog messages. So I'm going to close this screen, and now that we come back to our Citrix application, the one where we just adjusted its drop rate or its queue size, notice here how we're no longer dropping any traffic. We've now flatlined at a 0% drop rate. Our red line is no longer spiking. So that's good. We have adjusted this queue and we've fixed that QoS issue. So this brings us to step 3 of our conversation. This is going to be that of buffer tuning. And again, this is going to be an advanced concept that we are going to touch on it because it is very important. So what I'm going to do is I'm going to focus in on this video class or this video queue. Notice how even with QoS in place on this video queue, we are dropping traffic. And if we come and look at the configuration of the video queue, we have given the video queue, in this case, a priority queuing configuration, and we are reserving 30% of the interface's bandwidth. In this case, we're actually reserving 30% of the traffic shapers bandwidth, and our traffic shaping value is 1 megabit, so 30% is going to be 300K. So that means we are allowing 300K within this class or queue. If we go back and look at the real-time bandwidth statistics of this class or queue using LiveAction, we can actually drill down and see exactly what is happening with this data. And again, what's so powerful about LiveAction is we'll never average or aggregate data. So we'll always be able to see exactly what is happening on this queue or this interface back in time. And I'll show you exactly how to do that in just a moment. So let's look at what's happening here in real time, just since we're looking at this screen. And what we can see is video is what you could think of as a very bursty application. These bursts are most likely the iframes, or where a full screen refresh is going to happen with the video conversation, followed by just the minimal details of the frame updates that would be occurring. So video is always going to be a very bursty application. And when it comes to capacity planning for video, I would highly recommend always making your queue size be 20% higher than you expect your video transmission rate to actually be. Along with that, what we have noticed is this. Notice how our bursts are maybe tapping out right at 300K, right at what the queue size is for this video class or queue. And if I wanted to adjust this queue and ensure that this queue can handle the bursts that are inherent with video, I am going to come to our video queues, queuing parameters, and I'm going to increase this priority queues burst size. This is going to be the BC, or the committed burst rate, and I'm going to make this rate actually be 120,000. Now, understanding how I came out with that number is not going to be part of our conversation today, but at the end of our session today, I'm going to have several links and several resources, and by researching those links, you will find exactly how I derive that number. So now that I have implemented that change or tune the buffer size of my video class, let's see if we don't have a performance change with our video. And I'm going to be looking at this in real time, and notice how just a few moments ago we were seeing drops based off the red lines in our video, but now after we've made that change, we will no longer be dropping any video traffic. We haven't increased the bandwidth amount, but we have tuned the buffer size, so we are protecting our video against all the bursts that are inherent with that type of technology. All right, so we're looking pretty good now on our QoS policy. Notice how the only drops that we're seeing, the only amber cues we're now seeing are that of our class default. And again, amber in LiveAction is our warning showing us that there are active drops happening. So this is really a great sign, because what this tells us is that we are protecting all of our priority traffic. None of it is amber, but we are dropping our best effort traffic. That's exactly what we want in our QoS deployments. So this brings us to our step 4 of our conversation we just had in our slideshow, and that is we need to now implement our throttling of traffic. And remember how when we had looked back at our historical reports, we had highlighted that there had been some BitTorrent traffic as well as YouTube traffic. Why don't we implement a scavenger class that is known as a less than best effort class and police this traffic so that BitTorrent and YouTube does not overrun our network? And let me show you how we can do that. I'm going to right click on my data center device, go to QoS and manage QoS. And what I'm going to do for simplicity's sake is I'm going to implement a scavenger class on this queuing policy here. And again, remember, this queuing policy is nested or a child policy of our shaping policy. And so I'm going to right click on this queuing policy. I'm going to say add class to policy, and I happen to have already pre-canned a scavenger queue or scavenger class. I'm going to go ahead and add that to our queuing policy. Just to save time, you don't need to see me type, and what we already have pre-embedded in this scavenger class is we are going to be matching YouTube traffic as well as BitTorrent traffic, and we're matching this against NBAR application recognition. So what I need to do here is I need to enforce a policer on this scavenger traffic. So what I'm going to do is I'm going to go to my policing tab, click to enable policing. I'm going to give this a committed rate of just 1% or 10K of the bandwidth's shaper amount. I will make my conform action be transmit and my exceed action be drop. So this means we can have YouTube as well as BitTorrent send up to 1% of the shaper's rate, and anything above that will now be dropped. So what I'm going to do is I'm going to click Preview CLI. I think that change looks pretty good. I'm going to now save this configuration, and here in just a moment we are going to see where we are now dropping our BitTorrent as well as our YouTube traffic. So here in just a second, we'll see SMP catch up. And while we wait for SMP to catch up, what I want to highlight for you is our historical QoS reports. Like what I mentioned a few moments ago is we'll never average or aggregate data. And this means we can go back in time and say if we want to go for the last hour, 6 hours, last day, week, or even a custom time interval, say 2 weeks ago, and we wanted to know exactly how any one of the queues is performing in your environment back in time, we'll always be able to show you this at the same level of granularity as we pulled it at. So utilizing this tool, say a help desk ticket comes in and says, hey, we're having performance issues. Well, utilizing LiveAction, we'll always be able to go back and replay exactly what happened in your QoS policies, just like was happening right now in real time. So I'm going to close this window, and remember how we had implemented a scavenger class? Well, notice how our scavenger class is now the class that is amber. If we look at our drop rate, we can see we're actually dropping a whole lot of traffic. And if you look at the match criteria of this class, we can see we're actually mapping out the current YouTube and BitTorrent traffic, and we can see, yes, YouTube and BitTorrent are matching this policy, and we are dropping them at a very high rate. So this is looking good. We're actually, at this point, protecting our class default traffic because we're dropping our less than best effort traffic. So now that we have done all of these things, we have completed our 4 steps for implementing a QoS policy effectively on a network environment. But before we leave LiveAction, I want to leave with one last thought. Remember how we'd implemented that media trace and we had seen issues or drops with our voice over IP call. Well, what I'm going to do is I'm going to go back and I'm going to go back to my table view, and I'm still looking at just that one voice call, and I'm going to again execute my media trace. And this time when I execute my media trace, let's see if our performance does not improve now that we have appropriately configured our QoS policies. One thing I'll mention here is our Cisco telepresence video codecs. They can actually now participate in this media trace functionality with something called MSI. And what MSI allows us to do is actually kick off a media trace of one unique call from the video codec itself. We'll get trace information through all the network hops that it travels, and then we can also take trace information from the far end telepresence unit. So truly having a real end-to-end application view of exactly how your video calls are performing in your environment. So now that we've implemented this media trace, notice here how both our data center and our remote site are reporting 0 packet loss. This is great. This means that we are adequately protecting our voice and our video across our network environment. So at this point, what I'm going to do, I'm going to flip back to our slide presentation, and let's talk about the final topic for today, and that is QoS deployment strategies. And I'm going to very quickly talk through 7 QoS deployment strategies, and these are this. Step 1 is I highly recommend using NetFlow when it comes to capacity planning. As we've seen today in our real live example using LiveAction, we have the ability to highlight for you how much traffic is flowing through your network environment, where is it flowing, and you can drill down and know exactly with minute-by-minute time granularity what is happening in your environment. When it comes to QoS capacity planning, you definitely need to be looking at your flow data in 1 minute or better granularity, and LiveAction does provide that. Secondly, what we need to do when it comes to understanding QoS is we need to understand our applications. And for this, I'm actually going to flip back to LiveAction. And what I'm meaning by that is this. I'm going to come back to my real-time queuing statistics, and let's just look at my voice over IP. And what I'm going to do is I'm actually going to kick off a second voice call. And while I kick that off, we'll talk about what it is we're looking at. So I'm going to drill down into the voice that has been occurring in my network environment. And the main thing I want to show you is we have approximately 80K of voice traffic passing through this network. Now, if you go back and look at voice over IP documentation, you'll understand that 80K is the amount of bandwidth that a G711 call will typically use. Well, we can see very evenly and very consistently one voice call is using 80K. I just kicked off a second voice call, and I'm going to reset my Zoom, and what we're going to be able to see is this second call is going to add up to right at approximately 160, 165K of data. So voice over IP stacks on top of each other very nicely. One call, second call, third call would be 240K, etc. So it's a very easy type of application when it comes to capacity planning. Unlike video, remember how when we looked at video and we tuned our video policy, we had to tune against the peaks and valleys because it's so bursty. So it can definitely be a harder application to run QoS against, but by using a tool like LiveAction where you can get this granular view, you can visually see exactly what's happening with those bursts and be warned about when you are having queue drops in your environment. So it becomes very simple to tune your video policies. Now, a third application type that I want to highlight is our Citrix application, and our Citrix application is what we call a transactional application, and it actually has a lot of voice-like qualities where it will typically send at very consistent transmission rates. So a transactional app is one that usually can just do the math of stacking calls on top of our sessions on top of one another. This is unlike what we would maybe think of with, say, a bulk data type of application, such as potentially web transfers. I'll look at maybe some HTTP flows, and notice how HTTP flows that we're looking at here from our NBAR data are very bursty because they're using TCP, and TCP is always going to try to ramp up and use the most amount of data it can, so it will always try to utilize all the bandwidth you give it. So many times adding bandwidth to this TCP application may or may not actually be the right answer. Maybe it's going to be some other QoS technique, because no matter how much bandwidth you throw at a TCP app, a well-written TCP app will always try to use all the bandwidth. So I'm going to flip back to our slides now, and let's talk about the third step in QoS deployment strategies, and that is get businesses buy-in. Obviously, we're going to be IT, we're the network engineers. We know how much data is flowing across our networks if we're using tools like LiveAction. We understand how QoS works. But to ensure we have successful QoS policies and projects, we need to get the buy-in from the business, ensure that when we are successful, they also view our success as meeting their criteria. An extremely, extremely important step in QoS projects. A fourth step that we need to talk about is, again, not all devices are created equal. We need to understand our network and the devices in our network. Now, I've listed out several Cisco model devices, and each one of these devices will have different QoS configuration methodologies. The way to find out more about this is, A, go to Cisco's website, but B, I would highly recommend checking out the Cisco SRNDs, their design guides, especially their QoS design guides. If you're deploying QoS at the LAN level, I would highly recommend checking out this design guide I have highlighted here on the slide, the MediaNet Campus QoS Design Guide 4.0. As you go through this design guide, it will give you several real examples of how to configure QoS on the various platforms in your LAN environment. And one thing I'll leave you with on this slide is with your switches, I highly recommend starting with SRND for Auto QoS. Auto QoS's ability to just issue a few commands and via macro, Auto QoS will flush out a full configuration in your LAN devices. These configurations can become quite complex, but Auto QoS simplifies that. Now, if you read the details of this guide and what I have also confirmed from practical experience, you will definitely want to tune SRND for Auto QoS to your network's needs. It really needs to be looked at as a very good first step or very good starting point. Step 5 of our deployment strategy is have a plan. I definitely recommend over-documenting up front, and then when it comes time to actually implementing your QoS policies, that's almost secondary because you've over-documented your environment. The way I do this is I'll start by building spreadsheets. In my spreadsheets, I'll list out all the relevant QoS devices. I'll then list out the software version numbers as well as the interfaces bandwidth and any QoS policies that may be existing both on the devices as well as maybe service provider QoS policies. Any details that I think may be relevant to the QoS project, I will put in the spreadsheets. As well, I will make Visio diagrams. Here's an example of a Visio diagram I would typically use, say, for a WAN environment. Fill in as much data as you can on these QoS-specific Visio diagrams or network diagrams, and these are great ways to pre-document your solution. So when you're finished with a successful QoS project, you can hand off this already created documentation to the business owners, managers, or network teams. And then the final thing I'll do with have a plan is I like to use project. I'm definitely no project manager. I'm just an engineer. But what I've found is by having an extremely detailed project plan listing out all the logistical details of my QoS rollout, I will have pre-thought about all the steps I'll need to make, and this just helps me be that much more accurate when it comes to implementation. Step 6 of our QoS deployment strategies is use QoS management tools. As we've seen today with LiveAction, we no longer have to scroll through those literally hundreds of lines of very complex CLI to configure, deploy, edit, and validate our QoS policies. I highly recommend using a tool like LiveAction. As well, you need to use QoS management tools that will help you with both real-time as well as historic capacity planning. LiveAction fits that bill as we've seen today. As well, I would also pick a management tool that allows you to manage by exception. After you've finished with a QoS rollout, if you tune LiveAction appropriately and set up its alerting capabilities and get alerts and email and syslog messages, you should not have to do continual care and feeding of your QoS policies. You should be able to get alerts of queuing events or application performance issues when there are problems, and then immediately drill down into the timestamps of the various technologies in LiveAction and know exactly what's happening with a very granular level of detail. A huge time saver when you use tools like this. And the final step and point I'm going to make today is keep it simple. QoS is an art form. It's an extremely complex series of multiple technologies all having to work together. Maybe you need a 12-class QoS model. Maybe you only need a 3 or 4-class QoS model. Anything you can do to keep your QoS configuration simple, I highly recommend doing so. So guys, this brings us to the end of our conversation today, and a final thought I'll leave you with is I have listed out several resources, and either these are portals or actual documentation to learn more about the various components of how we configured QoS today. All great resources. I've found them very effective. And these resources will be available when we post this webinar here in just a while. And finally, thank you so much for attending. One thing I need to mention, as LiveAction 3.1 was just released a couple days ago, we really have some great new features in 3.1. Feel free to go out to our website, download a free copy of this, and you can try LiveAction in your own environment. And feel free to reach out to me as a technical resource to help you as you go through your evaluation of LiveAction. I'd be happy to do that. Thank you so much, everyone. Have a good day.